Hello and welcome to another complete Edexcel GCSE PE lesson, where you'll learn absolutely everything you need to know on topic 2.1 on lever systems and mechanical advantage. So you need to know about the three classes of levers and their use in physical activity and sport. So a lever consists of a solid bar or lever arm that turns around an axis or pivot to create movement. Levers are made up of four different components: the lever or lever arm, fulcrum or pivot, effort, and load. In the human body, levers are bones, fulcrums are joints, effort force is generated by the muscles, and load force comes from the thing you are attempting to move, which could be an external object or a body part. There are three classes of lever that you need to know: first class, second class, and third class. With first class levers, the fulcrum is located between the effort and load forces on the lever arm, just like a conventional seesaw. The neck joint is an example of a first-class lever, as the fulcrum sits between the load and effort forces, which come from the weight of the head and neck muscles respectively. This lever is used when heading in football, looking up to take a high catch in cricket, or tucking the head when performing a somersault. Other examples of first-class levers include the elbow during a tricep dip, with the elbow joint as the fulcrum between the weight of the body and the triceps muscles, and rowing, where effort from the rower and load from the water are applied to either end of the oar. With second-class levers, the load force sits between the fulcrum and effort force. The ankle joint is an example of a second-class lever, as the fulcrum is located at the joints between the toes and the ball of the foot. The weight of the body is the load, and the gastrocnemius or calf muscle provides the effort. This lever is used to plantar flex the ankle when performing a layup in basketball and to point the toes in gymnastics. With third-class levers, the effort is located between the fulcrum and load on the lever arm. Most of the levers in the body are third-class levers. A good example is the elbow during a bicep curl, as effort is generated by the biceps muscle, which sits between the fulcrum and the load, which comes from the dumbbell, as well as the weight of the arm. Other examples include a forehand tennis stroke with the effort applied by the pectorals between the fulcrum, which is the shoulder joint, and load from the ball and the racket, and kicking a rugby ball, where the effort from the hip flexors and quadriceps is applied between the hip joint and the load, which comes from the ball and the weight of the leg. Next, you need to understand the terms mechanical advantage and mechanical disadvantage. So levers operate at a mechanical advantage when the effort arm is longer than the load arm. In other words, the effort is further from the fulcrum than the load. This configuration allows large loads to be lifted with a relatively small amount of effort, giving the benefit of strength. First-class levers can have a mechanical advantage if the effort is further from the fulcrum than the load, while second-class levers always work at a mechanical advantage as the load force is in the middle. For example, when running, the second-class lever at the ankle joint allows the gastrocnemius or calf muscles to lift the entire weight of the body with relative ease. As a result, long-distance runners are able to work for long periods of time without tiring. Now, the downside of this configuration is reduced speed and range of movement. The load is moved over a much smaller distance for a given muscular contraction, resulting in slower movements. Levers operate at a mechanical disadvantage when the load arm is longer than the effort arm. In other words, the load is further from the fulcrum than the effort. This means that a large effort is required to move a relatively small load. Third-class levers work at a mechanical disadvantage as the effort and the load are both on the same side of the fulcrum, but the effort is closer to the fulcrum than the load. Now, the benefit of this configuration is that small muscular contractions of only a few centimeters can move loads over far greater distances, improving speed. For example, when kicking a football, the third-class lever at the knee joint produces high speeds over a large range of motion, generating power at contact. Well done, you've just covered absolutely everything you need to know on lever systems and mechanical advantage. If you have any questions, leave a comment down below, and I'll see you next time for topic 2.2 on planes and axes of movement.